Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, we will be discussing about the applications of linear algebra in data science domain. I think till so far, I have explored on my channel with respect to the statistical concepts. I have talked about that how the knowledge of stats is really important to get a clear cut idea about any data specific domain, whether you want to enter into data analytics or you want to enter into data science, right? Even I have curated a complete playlist for the same with respect to the statistics for data science. But now in this specific video, I'm attaching one of my very important session where I'm discussing about that how linear algebra knowledge, when we talk about linear algebra, we're talking about scalars, vectors, eigenvalues, eigenvectors. We're talking about matrices, operations of that. We're talking about the different operations that we can do on vectors. So how that knowledge is really helpful and critical to understand if you are planning to decide to go for this specific domain of data science. So I will provide you a brief overview in this specific session. Please try to watch it till the very end. Also, in this session, I'm sharing one important resource to refer. When I was learning these specific concepts, I referred the MIT lectures of Gilbert Strang. So I will try to share that in the description of this video also. It's a free open source resource. So if there is anyone who wants to plan to move into the specific domain, I would highly suggest that please try to watch his lectures. His lectures are in a very complete detail of approximately 1 hour each. And I think there are 34 to 37 lectures are there. I'm not sure. You can just check it out. I'll try to share the link in the description of this video as well. Are really interesting chapters, the way he taught everything. It's pretty cool. So please try to watch his videos also, but first of all try to understand that why it is important to understand these concepts. So I hope that you will find this video very insightful. Please do share this video with everyone on LinkedIn. Also you can tag me. I am really requesting you everyone to subscribe to my channel as well, because it really means a lot to me and it really helps me reach to the wider audience. With this, let's get started. So, linear algebra is a branch of mathematics that heavily deals with vector spaces, linear transformations between them, vector spaces, linear transformations between them. It's fundamental in many areas of mathematics and applied disciplines like computer science, data science, ML, physics, engineering. So I think when we are in the school at in the classes of I think 10th, 11th, 12th, somehow we have learned about the concepts of linear algebra in our physics and mathematics part, right? At its core, linear algebra focuses on the study of vectors, matrices, system of linear equations. So I remember, I think in our 11th or 12th, I don't remember the exact class, but in our CBSE curriculum, we have a topic of systems of linear equations where we usually try to solve the linear equations, getting the results, how can we solve them, how many different kinds of transformations we have, another ways, matrices, determinants, properties of that, how many operations we have, how can we do that, everything I think you also have learned in your lower classes. Can I say everyone, have you explored? Do you have an idea? Is there anyone in the class who is like Ki, I have not in my lower classes explored about this domain, I don't remember or I don't explore anything about this? I think everyone at least once have explored this linear algebra domain, right? So it's just that kind of a revision which will happen when I'm saying that data science ML domain is required with respect to linear algebra. It's not that something hi-fi linear algebra things will be required. That specific knowledge, if you remember, that is more than enough. It's just that because after that we have worked a lot in the industry, or we have already been there in BTech, that is not focus is not that much on mathematics part, we might forget that. So let's try to revise those concepts and let's try to learn about this specific domain in a lot more detail. Now, whenever we are talking about this linear algebra domain, we have learned that okay, it's a component with respect to vector spaces or vectors. So we have to learn about what is scalar, we have to learn about what is vectors. But before diving into that part, the very first thing which you have observed in this definition is that the application of this is applied in a lot many domains. And when we are talking about the foundational concepts, foundations of ML, because see, my main focus over this specific course is to talk about everything with respect to data analytics, because I know that my audience wants to deep dive into that specific domain. So we will try to focus more on how in data analytics, in data science, this specific domain is important to understand. Remaining things, physics, engineering, computer science, definitely I'll not touch upon. I'll majorly touch upon this specific part. So when we talk about data science, we have a ML concepts, we have a deep learning concepts, we have a NLP concepts, we have the computer vision concepts, right? So in all these foundational knowledge, this concepts of linear algebra will be applicable. Now, how this will be applicable, what are the applications we have in this specific domain? Let's try to deep dive into step by step so that we will be able to appreciate that why we are learning these things. The very first thing where you will observe that in this data analytics and data science domain, this linear algebra is heavily being used is in the data representation, data representation and manipulation part. So you will observe that if let's say I want to represent my data, let's say you are creating any model. Now again, as I told you, there might be people in my batch who are not aware about uh, anything related to ML, anything related to DL or NLP. It's completely fine. Just try to consume whatever you can, and if you have any question, please ask me on the spot. I'll try to answer it and maybe provide you the explanation in a more layman manner. Okay. So let's say that we are trying to train any model. Maybe it's a machine learning model, it's a deep learning model, it's a NLP specific model, depending upon which kind of data you have, right? Now, what usually happens is, let's say you will be having the features. Now, the features are called as columns in the space of data science. Okay. So let's say you are working on a task where your task is to predict the price of flat, let's say in a white field area, specifically in Bangalore, I'm talking about. Now, there are in my society, let's say, multiple flats which are on sale. And I just want to see that maybe if I'll just purchase this flat right now, how much is the price after 5 years? Like, is that increasing? First of all, definitely it will be increasing, but by how much percentage? Is that percentage margin is 10%, 12%, 15%, 20%, 25%? And it depends on the locality, it depends on the area, it depends on the outside region, it depends on how far is the metro station, it depends on various factors. Now these factors are what we call as features of a given data. And just to demonstrate in a simple manner, for example, I have for now three features. One is the area, like how much is the volume of my flat. Second is the number of rooms. Is that 2 BHK or 3 BHK or 4 BHK and so on? Is that where is the location, like where it is available? So let's say I'm saying that the area of my flat is maybe 1500. The number of rooms, it's let's say 3. Location is, as I told you, it's in a Bangalore. So this is location we are talking about. And what we want is the price of that specific house. Now, to get the prediction done, we definitely have some historical data. Historical data meaning that in the past, maybe I have few months back, what is the price going on? What was the price going on? I have a huge list, a CSV file for that. I will use that file to train the model, and then in future Whenever I'll try to provide these input features F1, F2, and F3, it will be able to give me the prediction that, let's say, the price of the house is 4.3 CR. Let's suppose. Okay. Now, when we are talking about this F1, F2, F3, we want to store these numbers. We want to store these numbers, right? It may be, or you can say, input features having value, first value is 1500, second value is 3, third value is the location, which is Bangalore. And this is the input space that you have, which is composed of the features like F1, F2, and F3. And this is something which we called as vectors. So, what are vectors? Vectors, simply in other terms, in a layman term, you can say it is composed of multiple dimensions. So, it's a kind of a multidimensional array based data structure. For example, if someone will ask you that how much dimensions do this vector have, so you will say that it's a three-dimensional array. It's a three dimensions. Dimensions meaning that how many number of features for now you are working over here. So in this specific instances, here linear algebra plays a very important role in terms of, you can say, storing the data, representing the data in an appropriate manner. There is one more thing which you will heard in the space of linear algebra called as scalar. Anyone who knows the difference between scalar versus vector? Scalars versus vector? Any idea? Anyone? So if we are talking about scalar and another way we are talking about vectors, what is the difference between these two? Any idea? Anyone? Vectors. So in physics, we usually say that scalar is having just a magnitude, vector is having a magnitude plus direction. But in the terms of data science, this direction word doesn't as such make sense. So, in terms of data science, the way to interpret these things is that when we're talking about scalar, we are dealing with a single value. We are dealing with a single value. For example, let's say I will provide you a data set. And in that data set, I'm saying that can you tell me what is the mean of this data? Mean of, let's say, any specific feature F1 or any specific feature F2, right? Mean of any specific column. Or I'm talking about, can you tell me what is the median for the same, which we called as 50 percentile, and so on. So basically, if I'm looking for a single value, that is where we talk it in the terms of scalar quantity. That is what we call as scalar quantity. What is the meaning of vector quantity? The simple literal meaning is that in this specific scenario, we are dealing with a dimensions, multiple dimensions. It is not composed of a single value. Is that part is clear to everyone? Any doubt till so far? Anyone? So it's kind of a vector is in the data analytics term is a, you can say, one dimensional array of numbers that represents the data points that we have in a given data in a structured form, in a numerical form. Now, this is where the role of linear algebra comes into picture. When we are talking about manipulation, it means that you will do the operations on top of that. You will do maybe any scalar operation or vectors operation on top of that to manipulate your data. When we're talking about vector operations, there are multiple operations we have. For example, how can we do the addition of two vectors? How can we do the multiplication of two vectors? And how can we interpret them? So this is where the data manipulation task will come into picture. I'll talk about this in a lot more detail, but till so far is everything is clear to everyone? Yes, in this case, you will say that this specific vector has three dimensions because there are three features we have. In future, let's say if I'll say that I'm having 500 features for a given data point. So in that case, the vector contains a 500 dimensions. That's the way to interpret that. So that is the very first advantage which you can say is a part of a linear algebra. The second dimension, the second advantage will be that when we are talking about in terms of machine learning and artificial intelligence, you must have seen that when we are doing a model training, when we are doing a model training, for example, let's say you are applying a simplest model which we call as linear regression. So you must have seen that in these kind of models, we are trying to do a we are trying to do a generalization of the model. We are trying to do a generalization of the model in such a way that we will be able to get a line which is y is equals to mx plus c, right? So this is again, what is this called as? It's a set of linear equation. So we are trying to simplify these linear equations only. So if there is anyone who is not aware about linear equations, linear algebra, they won't be able to understand how this m, which we call as a slope, will be computed, how the c, which we call as intercept, will be computed. So again, to have a better idea, this linear algebra plays a very significant role. In the third application, you will observe that in machine learning, whenever you will study, you will observe that there is a techniques of dimensionality reductions, where the main purpose is that we want to reduce the dimensions. What is the meaning of dimensions? I already told you. Number of features. So if let's say you are dealing with some data set, and in that data set you will be having 500 features available with you. Now we usually have an assumption that if we will be having too many features, the model will be able to give us an appropriate result. But this is not something which is always true. Sometimes our model gets confused, it gets complex, and it won't be able to give us a better results. That is where we need to reduce these features. We need to reduce the dimensions. We need to reduce the dimensions by retaining the important information, by retaining the important information. So we don't want to lose the information of these 500 features. We need to retain them, but somehow we want to reduce the dimensions as well. And that is where in our machine learning, we have techniques called as PCA. We have a techniques called as TSNE. These are the algorithms that we have, which basically used internally the concepts of linear algebra like eigenvalues, eigenvectors, to specifically do the task. So again, that is again a very significant reason why this linear algebra knowledge is required. Afterwards, as a fourth part, you will be able to observe that whenever you will be working in future with respect to the deep learning algorithms, there is a concept of convolutional neural network, CNN. Convolutional convolutional neural network, where you will observe that if let's say you are dealing with images and your task is to, let's say, do the image segmentation, or your task is to do the image recognition, right? In all these instances, wherever you are dealing with images, you are applying CNN based algorithms, and internally they are using the matrix operations, like you can say transpose of a given matrix, you can say multiplication of two matrices, right? So if you are not aware about these specific concepts, you will face a trouble that how internally this convolutional neural network is working. Always remember, whenever you are seeing any image, right, these images will be stored internally in any given you can say database in the form of a pixel value, right? For example, if let's say you are saying that uh, I am having an image of maybe 20 cross 30 dimensions, so it means that 20 number of rows, 30 number of columns we have. It means that every image internally is composed of pixel values, and there is an internal matrix operation going on, which is basically doing a task which you want to perform. So there's a complete maths of matrices which is doing the task of you can say deep learning algorithms or convolutional neural networks. when we are reducing the dimensions, are we removing the outliers? No, there is no interconnection between the outliers and the dimensional part. We are reducing the dimensions because these many dimensions, which is 500, is too high. And that's a problem. Why? Because the training time, which internally my model will take, will be very high. The training time will be very, very high in these kind of cases. Second thing is, as I told you, that model will become complex and it won't be able to give you a good results. It's kind of that if I will start feeding you more knowledge, you will not able to consume, right? You will be like that, I'm not getting anything. Same thing is happening for the model as well. If you are giving more features, it will, at the end of the day, become very complex. Again, it's very difficult to visualize what is happening internally, difficult to visualize for us as a human being. So whenever we are doing any training of a data, so there is a complete maths behind that. But when we have these many dimensions, we cannot able to understand that how mathematically things are going on, because as a human being, we also have a limitation. We cannot understand 500 dimensional data. Third, fourth thing, that again, if the training time is really high, definitely there will be a huge amount of resources requirement will be there, which will come up with the cost. So the cost will be very, very high. It will require a, GPUs. It will require a, I would say, full-fledged great GPUs, which is very, very costly, believe me. And it's really hard to afford it by self, until or unless you're not working in some bigger companies or you're not collaborated with the clients. It won't be easy for you to do it on your own, right? Even getting a Google Colab Pro subscription might feel for few people expensive. So you can imagine that if you will try to have a great GPUs of your own, it will be a very expensive task for you. So that is the main reason, combining together, why there is a need to do the reduction of dimensions. But at the same time, we want to retain the information as well. That is where these techniques will come into picture. So this is not at all interconnected with the outliers. I hope it answers your question, Mayur. And on top of this, when you start learning about these specific domains, which is ML, DL, NLP, whatever points I'm saying, anyhow, you will always have these videos with you. You can again rewatch these videos, because these things, these domains, you will not able to get an idea within few days, within few months. It's a long process, it's a long journey. You never know that at what point of time you are starting and learning, exploring about NLP, large language models. So it's just that when these things will you will learn, you will understand that, okay, some time back Priya told us that this is where linear algebra is being useful. So okay, today I am seeing that how actually things are helping. And for those people who are already aware about these domains, they definitely easily able to relate that what I'm trying to convey over here. Yes, shall we move ahead now? Perfect. So we have talked about until so far how many applications? I think I have talked about four applications. First application I have talked about in terms of representing the data and manipulating that in the form of scalar and vector quantity. Second thing I talked about in the terms of model training. At any point of time, your main aim in the model training is to generalize the model by some set of equations. For every model you will observe, there is an internal equation going on. There is a set of equation. For example, just to give you an example, there is one model called as linear regression, for which we worked with this linear equation, which is y is equals to mx plus c. And our main goal is to get that most optimal values of most optimal values of m and c, right? This is our main goal. So in those kind of instances, you will definitely able to observe that this linear algebra knowledge will help you significantly. Third application I told you is in dimensional reduction, where you will observe that at any point of time, if you want to reduce the number of dimensions, you have to apply the techniques of PC and Tisney. Internal maths is related to eigenvalues and eigenvectors. Today, I'll not explore more about this eigenvalues and eigenvectors, but in the upcoming class, We will do some numerical questions or examples to understand the internal intuition behind these two values as well. Fourth application I told you is in the space of a deep learning, where you will be able to observe that there are almost all the algorithms which works under the core idea of CNN, convolutional neural network. If you don't have any idea, again, you can go and explore about this, how this work. But internally, you will observe that this algorithm is using the matrix operations, matrix first of all to store the images. So as I told you, all the images that you have stored in the form of matrix, and matrix meaning that it is composed of rows and columns, and internal quantity is the pixel value which you will be able to observe in these specific cases. Now we usually apply on top of this the matrix operations like transpose and multiplication in CNN. How actually these things will work, what kind of operations it will apply, hey, it's not my task, right? Because you're here learning for statistical part, not deep learning part. When maybe in future I'll launch a separate course for deep learning, then we will deep dive into how CNN works, what's the maths behind that. But the beauty about this course is that now you know that, okay, what is the mathematical thing and how you will be able to relate with the deep learning stuff or NLP stuff in future, or ML stuff as well. So I hope it makes sense, right? Let's try to touch upon NLP as well for those people who have an interest, or maybe in future they're planning to go into that space. How this linear regression is again helpful in that specific core space. Let me try to give you an idea for that part as well. And then maybe I will for now stop this topic of applications part and we'll move to the next topic. So, in the space of NLP, the full form of NLP is natural language processing. By the way, if you will be able to observe, in data science, we have all of these spaces, but the core difference lies among the data set that we are having. Data set is the main thing, core thing in this space of data science. If let's say you are having a numeric data, chances are very high that you are dealing with machine learning based algorithms in those instances, where we have the algorithms like supervised, unsupervised, semi supervised, again depending upon what kind of data you are dealing with. But you will observe that, for example, the banks is a very good example. The banks like HDFC, the banks like uh, ICICI, right, SBI, and many more, whatever banks you know, uh, at your space, at your location, all these banks have a data scientist working internally in their branch. Almost every bank is hiring nowadays this specific data analytics and data scientist people. Why? Because internally you will be able to observe they are analyzing your data. They will get to know that, okay, this person requires loan and we should give them. This person does not require loan. You on a daily basis used to get a call from the banks that, okay, we are providing you a free loan offer with respect to this the amount. How they will get to know? How they're calling you? They're analyzing your data. They know that how much per month your transactions are happening, how much salary you are earning on a monthly basis. So what capacity you have to repay the loan amount. Definitely they don't want defaulters at the end of the day. When we are dealing with in a dataset aspect, image based data, so that is where, for example, you might have seen the problems of healthcare, where the task is to detect the cells of cancer, right? There is a very famous problem in image called as image segmentation. This is where I have done my whole research in my master's program. It's a very famous problem. The simple meaning of this specific problem is that, for example, I'll showcase you one example so that in a layman term you will be able to understand what I'm trying to convey over here. In a, let's say, cancer uh, cells, let's see what images we will be able to get over here. If I will be able to get any good image, I'll showcase you. So this is the meaning of image segmentation. Let me just save this image. It's day number 7, right? So let me just try to fetch it up in the PDF. So you can see this image, right? So here, this specific image, I think what data they are taking up, let me just check it out. Automatic cell nuclei segmentation classification of breast cancer. So you can maybe have a read about this research paper, but overall, which I can see over here is that they are diagnosing the breast cancer overall in this specific image. So can you see that this is the meaning of segmentation? When I'm saying segmentation, first of all, they are trying to, take that, you can say, area of region. This is what we called as in a deep learning space, region of interest, region of interest, area of region, or we can call it as a region of interest. Even the same thing you will find in my research paper as well, which I have written at my master's research. So the very first task is to get that region of interest, and then they are trying to diagnose this. They are just removing these white cells, and then they are getting that idea that okay, these are the specific areas of, you can say, the breast cancer specifically. So this is a kind of a task which we say as a image segmentation. So when we are dealing with images, that is where the core knowledge of deep learning concepts comes into picture. That is a separate domain altogether. So you will observe that all those companies who are dealing with healthcare domain, in a healthcare we have a mix of numeric plus image based data. So there is a separate team who is working as a ML side, there will be separate team who is working as a DL side in the companies. uh, uh, the gaming thing, right? The gaming companies are there. In that case, image based data they are dealing with. The Android team, those who are launching the smartphones, or maybe the Apple team, where they are launching their own iPhones. So that is where they are providing some great features in the cameras. They're providing some great features in the form of a face recognition. That is where the complete deep learning space is coming into picture. If let's say you are saying that I am having a data set which is of textual type, which is of textual type, so it's all a game of which kind of data you are dealing with, and that is where the kind of data you are in, your space will get changed. So if let's say you are dealing with the textual data, meaning that maybe the chat GPT, right? In that we are dealing with the textual data, or any form of large language models, right? That is where you will be able to observe this NLP space into comes into picture. And in NLP also, wherever you will observe that we are trying to generate anything out of that specific tool. For example, in this chat GPT, we are putting some question and we are getting some answer. Inside this NLP, we have a space of generative AI, which is quite common or famous nowadays. So many companies, many startups are easily getting a funding if they are working in this specific space. And I feel in the next 5 years, this domain will be quite booming. So if you have time, if you can do some real time projects, get some industry experience in this generative AI space, please do that. Because once that launch of ChatGPT happened, I think in November 2023, after that you can observe that how many new tools have come up, how many large language models have come up in the market. uh, Everything has changed. Right now our way of searching the things has changed. LLMs becomes quite famous. This is what we call as large language models, LLM. So it's a space of NLP. So it's again quite booming space. But by saying that, whether you are talking about ML, DL, or NLP, everything has its own features. And at the end of the day, you cannot become expert in all the domains, or if you can, it requires a lot of experience. So always try to start your journey with ML, then go to DL, and then, or maybe directly after learning ML you can go to NLP as well. It all depends on your choice. But better idea could be that first start learning about ML, then DL, do some projects on DL as well, and then maybe NLP will be really helpful. This is how I started learning. So this was my process. I first of all gained an expertise in ML, then I worked on DL specific projects. And NLP is something which is not that much strong currently. If I talk about myself, I'm working in the real time projects in the companies, collaborating with them to work with this generative AI field. So I think in the upcoming years, I will say that, okay, this is something where I gained the core expertise now. So this is how it requires a full-fledged lot of time to get the expertise. But this linear algebra is something which you will observe is a core part of ML also, DL also, and LP also. So once you start exploring the algorithms inside these spaces, you will get an idea why we are learning linear regression today. So that's the main idea. So in NLP, nowadays you must have heard something called as it's quite famous articles. You can explore about this after the session will get over. Vector DB, vector database. Have you heard of this thing? Vector DB, vector DB. Yes, it is used in RAG. What is RAG? For any cancer detection, can we use deep learning or no? Yes, for cancer detection, people definitely are using deep learning techniques. I think I just now explained you the process. So that is where deep learning specific algorithms are going on. Yep. So nowadays, as I told you, in a generative AI, things are going on a lot more space. So please start, at least reading some articles. I'm not saying that go in lot more depth, but at least you should have awareness what's going on in the market. So again, I'll not go in a lot more detail, but just to give you a context of linear algebra, because we are discussing today this specific subject, let me tell you how NLP domain is using this specific domain. So usually what happens is that uh, initially when this NLP domain comes into picture, the applications like, for example, Google Translation, that is an application of NLP space. So I hope you have seen that in the Google, if we will just see the translator, we have an option to convert one specific language to another language. For example, if let's say I'm saying that I want to convert maybe English to, let's say, Hindi. Let's say someone doesn't know Hindi language. He's coming from maybe outside India and they're not aware about Hindi language. They just know the English language because it's a global language. Everyone knows that. So one way is to communicate with English language to everyone in India. That's idea because of which English is very important, right? Globally, it is a common language which everyone knows. But let's say that guy is coming in India and he's staying in some area where maybe people are not that much aware about English language. They just know the local language of Hindi. Now the better idea could be that he will try to use the Google translator. So let's say if in an English word they are that person is saying that how are you, right? So internally my model which is there in Google Translator, you can just try and read the research paper of this Google translation. It's one of the amazing research paper. So internally they are using some algorithm which is called as transformer, which is the state of the art of the model in a, you know I would say NLP. And even this GPT, generative pre-trained transformer, if you will see the full form of GPT also, that is where again this transformer plays a very interesting role. So when we are doing a conversion of how are you, or when model is doing, it is converting that, let's say tum kaise ho, right? Tum kaise ho. So this conversion which is happening with respect to every three words, giving that Hindi word as tum kaise ho. So in this specific scenario, what is happening is internally there is somehow mapping is going on. My model will not able to understand these context of how are you ya tum kaise ho. What my model understood is the numeric data. That's the important thing which you always have to understand. If you're feeding the images, internally pixel value is going on. I told you, right? It's not that the image is going on, it's not that this cancer image is going on, it's not that the model will be able to understand these cells. It's just that internally this image is mapped with some numeric data which I'm saying is a pixel value. Similarly in NLP also, every word for example, how, are, you, is being mapped with some numeric data, which is what we called as a vectors. Few minutes back I told about, right? So every word is mapped with some numeric data. For example, let's say the mapping is, I'm again writing some random numbers, 15, maybe 12, 25. Let's say this is a mapping of how, this is a mapping of r, this is a mapping of u. So can you see again, this representation of vectors is an application of what? Is a subject of what? Linear algebra. So every specific English word, Hindi word, Telugu word, whatever words we have in the dictionary, in the Wikipedia, there is a pre-trained model we have, which is having an appropriate mapping for the same. So what is happening is that there is a concept, there is a concept in the space of natural language processing called as word embedding, which you will see when you explore this specific domain. The simple meaning of this word embedding is that every specific word we are trying to convert into embeddings, into vectors. And there are algorithms for that. For example, there is an algorithm called as word to vec. There is an algorithm called as TF-IDF. Uh, and there are many more, bag of words. There are many more algorithms we have, where the major task of those algorithms is to convert these specific words into vectors. Okay, and then they're trying to store the specific thing. On top of this, they're applying the operations on top of these vectors to get the core idea, to get the desirable results, whatever we want, whether we want the next upcoming word, whether we want a translation of the same word, and so on. So this is where again you will be able to observe this NLP comes into picture. This vector DB is a part of generative AI. So what they have done, they have used something called as a concept of RAG. So as I think, who's the one, I don't remember the name, I think Mayank. So he has already given the full form of this. The full form is retrieval augmented generation. So what is this RAG is doing? Let me give you a one simple example, and even you can watch one of my video where I have done a podcast with a girl, and she has done an amazing work in terms of Bhagavad Gita. So what she has done is she has also used a large language model. So let me tell you what she has done. That video is available on my platform as well in the podcast playlist. So there is a full Bhagavad Gita we have, right? So we have a Bhagavad Gita. So what she has done in her project is that complete book is there. Now we, if let's say there is a platform, for example, we have Chat GPT. So what she has built is Bhagavad GPT, something like that. Now what is happening is, maybe in this platform I'm writing one question: what is love? What is love? Now what is love? As per Bhagavad Gita, what it will do is, this Bhagavad Gita, let's say she has processed it in the English form. So we have an English version of Bhagavad Gita, also we have a Hindi version. So she has processed the complete Bhagavad Gita PDF into the platform. And now internally what will happen, every word of Bhagavad Gita will be converted into vectors. As I told you, our internal models won't be able to understand the English words. That conversion will happen. That conversion of every English word to vector or numeric data will happen. And they're storing those specific things into something called as vector database. This is what we call as vector DB. In a layman term, again, there is a lot more which we can explore about the same. But if I'll just have to explain you that what is this vector DB, that is what it is. So every specific word is being stored in the form of vector in this DB. It's kind of, we have MySQL, we have SQL, we have PostgreSQL, something like that. We have a DB database where each and every word, vector, or numeric value will be stored. Now, what is happening as soon as a user is entering a question, what is love? It will again try to convert that into, first of all, vectors. When I'm saying vectors, it means it will try to convert it into a numeric number, because my data or my model won't be able to understand English data. So it will try to give a vector. What is love? There may be mapping. For example, 15, 20, 25. What is love? Now, in this DB, it will try to check. It will try to do a searching operation. This is what we called as RAG. So RAG operation is something that it will try to retrieve the data from this complete vector DB and will try. There is something called as cosine similarity concept. So what it usually does is it will try to check a similar values. Wherever it will find out that this specific 15, 20, 25 maximum similar value is available in some vector, maybe 20, 15, or 22. So there is a metric that we have wherever there is a match. For example, let's say 95% match will be there with respect to any specific context. So it will try to fetch that data and deliver it to you. So what is love? Let's say whatever be the definition given by Bhagavad Gita, it will try to give you a response as per that. And this is what she has done. Even this is a similar thing every company is doing, I would say. Finance company having a banking data, they cannot share that kind of a data on a public platform, on an open source platform. So what they usually do, they try to train their own data on top of what pre-trained models that we have. So what usually, if you will start working in your companies, you will see that they have their own GPTs. Doctors have their doctor GPT. Banks have their bank GPT. LLM based companies have their own company based GPT. So what they are doing is they are trying to train their own data set which they can't load on an open source website, and that is where internally the same process is going on. You can train Bhagavad Gita, you can train any XYZ book, you can train a novel, whatever you want. For example, let's say you are fond of novels and you have a list or PDF of multiple self-help books. You are trying to feed those self-help books. Every specific word is converted into vector, stored in a vector DB. Now in future you have a platform like ChatGPT where you are asking some question. It is just checking a match with respect to the DB that you have and giving you a result. Imagine, this is how things are going on literally nowadays. So that is how this RAG world, generative AI world, vector DB world is going on. Now converting that every text into a numeric data is where linear algebra comes into picture, because whatever operations I'm talking about, for example, this cosine similarity has a formula that whatever this is, let's say a vector, this is let's say b vector. So it will try to check it's a into b divided by norm value of a and b. We will discuss in upcoming sessions how can we evaluate that, but the main point is that these are the operations of vectors. These are the operations of vectors, which is nothing but is an application of linear algebra only. So that is where I hope again uh, this specific domain is important to understand. So that is the overall idea about the applications of linear algebra. I hope that this gives you a motivation to not only follow these sessions which I'm teaching over here in these classes, but also try to refer that Gilbert Strang lectures which I told you in the initial part of the session, this MIT lectures, and go and explore about the same, because this specific lectures or this specific knowledge will not only help you to grab the concepts and to understand the algorithms in ML specific domain, but is also equally helpful in DL and NLP and generative AI domain as well. Make sense? Shall we now move ahead to the next topic? In case of, let me take few questions. In case of different words, vector dimension will be different, isn't it? No, dimensions will remain same. It's like if you have three words correspond to these three words, you have three values, three numeric values will be there. So dimensions will be, let's say three dimensions are there, so three dimensions will be there. That won't vary. So, okay, perfect. Let's move ahead now to the next important part. So till so far, I think we have discussed why there is a need to study about this specific subject and where it is really helpful. So we have talked about what is scalar, we have talked about what is vector, we have talked about the applications for the same. Now I think we can go and explore about the operations in the vectors part. I think that is where we should start now. Let me just check. Before that, are we missing anything? Yep, I think we can start with the operations part. So let's get started and let's try to discuss the operations of vectors and scalars. So let's talk about the operations in linear algebra. I'll talk about few of them which are again super helpful, but on top of that, please try to explore on your own and see whatever other things we can do with respect to these operations. So till so far, I think we have understood the difference between scalar versus vector. Scalar is a single quantity. Vector is kind of a one-dimensional array containing multiple array elements inside that, right? Now, let's say if you have two vectors available and you want to add those two vectors. Let's assume that you have the vectors like, maybe you are saying that I have two features available. Let's assume that the first feature is having a value which is maybe -4 and 3, and second point p2 is having a value, vector point having a value, let's say maybe 5 and 3. 5 and 3. So if you want to add these two vectors, these 2 points, p1 plus p2, so what do you think will be the answer we will be able to get? Any guesses? If I want to add these two vectors, which is -4 and 3 and 5 and 3, what will be the final answer we will be able to get over here? So many people have said that we will be able to get the answer as 1 comma 6, and that's true. Now let's try to understand it in a visual manner, that how this vector makes a sense and how these additions operations will be going on internally. So when you are saying -4, 3 plus 5, 3, so it will try to take -4 plus 5 will become 1, 3 and 3 will become 6. In terms of visuals, how these things will look like, because it's a two-dimensional data, so I think it's very easy for us to see visually as well. So let's try to focus. I think you must have done the same similar things in your lower classes as well. For example, the very first point we have is -4 and 3. So let's assume that this is -4 in the x-axis, this is 0. And let's assume this is y-axis we have, which is 3. So here, what we are doing is, this is what we have as -4 comma 3, right? This is what we have. So it means that our data point is located from origin towards this point as the very first vector we have, which is -4 comma 3. The second point we have available at 5 comma 3. So when we are saying 5, let's say 5 is available over here and 3 is available over here. So this is the point that we have, which we are saying it as 5 comma 3. So what is happening internally as soon as you are saying that I want to add these two words? So you are saying -4 plus 5, -4 plus 5. So what will happen is, it will try to move ahead towards this axis 1, 2, 3, 4, and 5. 5 points towards the right side, because you have plus 5, right? 1, 2, 3, 4, 5. It will reach this specific point. And now what you are saying is that I want to go towards plus 3. So that is where you will be able to, so 1, 2, 3, 4, I think it will move ahead towards 1, 5, and this is where it will try to move ahead to the plus 3 points. And that is where it will try to reach to this specific location, which is 1 comma 6. And this is where we will be able to get the entity, right, at exact location as 1 and 6. So this is what is happening in internal vector space, where it will try to take the number of steps with respect to how many data entries you want to explore, and giving you a desirable result. Is that fine for everyone? Shall we move to the next operation now? So it's quite simple. It's like whatever values you have. For example, if let's say you are having the values in a three-dimensional space as x1, x2, x3. When I'm saying three dimensions, I hope now everyone knows what is the meaning of three dimensions. We are dealing with internally three features: x, y. If I'll say y is composed of y1, y2, and y3. And if let's say I'm saying that I will be having a z as well in this case, because it's a three-dimensional features, z1, z2, and z3. So at any point of time, if you have multiple vectors and if you want to do the addition of all of these vectors, so simply what you supposed to do to get the answer. So what will be the answer you will be able to get in this case? Any answers can I get? So it will be nothing but the addition of, simply you have to do the addition of all of these points. So it will be x1 plus y1 plus z1, x2 plus y2 plus z2, x3 plus y3 plus z3. So this is how you will be able to get the exact result vector point where it will be allocated. And when you are having three-dimensional space, obviously this is how it looks like. So x, y, and z. And on top of that, 4, 5, 6, it's very difficult to draw and doing some imagination also. But there are nowadays tools available on the web. You can just explore to see the multiple dimensions vector, how it works. If anyone got great tool, you can just share in the Telegram group as well to visualize the multi dimensional vectors also. But it will be difficult for me to draw, but I hope that it makes a sense that how internally this structure is going on with respect to the addition of vectors, addition of vectors, and how this operation works internally and visually. Shall we move ahead to the next point now? Now let's talk about another interesting point and another important operation which you will observe in almost all the domains. It is super helpful apart from addition, and that is about the dot product. Dot product among multiple vectors that we have. For example, let's say you have again the point P1, which is composed of two dimensions having values 2 and 3. You have point P2 composed of another dimension, let's say 4 and 5. If let's say I will say, for example, few minutes back, I told you that this is the cosine similarity formula to check the similar value, how much similar the value available in a DB versus this user entry, user prompt, right? So this is the formula: A dot B divided by the norm of A and B. We will discuss about this norm, but we are discussing for now this dot value. So what does this indicates? How we can evaluate that? So if I'll say that, can you tell me what is the value of P1 into P2? By the way, this is the way to represent the vectors. This above arrow symbol will be there. But anyhow, anyone who can tell me, anyone, any idea, or you remember in your earlier days how we usually evaluate the dot product? Anyone? Tell me the answer, what you will be able to get. What's the way to evaluate that? Is that similar to the matrix multiplication, or is that something which is different? It's quite simple and it's not difficult at all. So what we usually do in this specific instances, whatever value you have, for example, 2 into 4, 2 into 4 plus 3 into 5, 3 into 5. So it will be 8 plus 15. So this is how basically we will be able to evaluate the dot product of any two numbers. So whatever value you will be able to get, I think it will be 23. if I'm not wrong. So this is the final result or the dot product we will be able to achieve over here. Is it fine? Quite simple, right? You will also in the standard books see one more term in terms of a dot product people are writing. So don't get confused between this term and if anyone is saying to you that P1 into P2 transpose. This is actually one and the same with respect to what we are doing. So what we are doing, yes, if let's say, let me generalize it just like the way Prabhutva has done. So let's say we will be having A1 B1 and A2 B2. So what we have done in this case, we are saying dot product is nothing but A1 into A2 plus B1 into B2. This is how basically we're getting the result. So if let's say you are seeing this kind of a term, you will see this heavily in the domain of deep learning when you are dealing with the neural networks. This transpose word, when we're talking about transpose, the literal meaning is that if let's say you are having a row, you will convert that into column. If you're having a column, you will convert that into row. So for example, you have P2 as 4 and 5. So what we are doing over here is that let's say the P1 is 2 and 3 in the column wise. Uh, this specific P2, which is 4 and 5, you're converting as column to row. So you will be able to get 4 and 5 over here. But definitely, when you're trying to solve this specific problem, you will try to say 2 into 4 plus 3 into 5. So result will remain the same. The approach will remain the same. It's just that the way to interpret the thing will be different. So you should know in this case what is the literal intuition behind transpose. Is that fine for everyone? So if in future you will heard this specific term as P1 dot P2 transpose or A into B transpose, W1 into W2 transpose, because in deep learning weights comes into picture in the neural network. So please don't get confused. They're trying to interpret the same meaning, which is the dot product for the same. Shall we move ahead? Everyone is fine till so far? Chale aage to the next part? Perfect. Few minutes back, I told about one more thing, which is this A1 and B. This thing I think now you know how basically. So if let's say you will be having a vector of 3 dimensions of A and B, how you will do the dot product, that you know pretty well now, right? What is this? What is this is indicating? If let's say I will provide you the vector A and B, what is this? This term is called as norm. So what is the intuition behind the same? Anyone, any idea? Have you heard this term prior? Norm. It's a quite famous term in mathematics, but I'm not sure how many of you are aware about the same. Any idea? Anyone? So norm is somehow you can relate it as a Euclidean distance with respect to the origin. Okay? Let me give you one simple example, and I think things will be pretty much easy for you to understand. For example, let's say I'm saying to you that A is a vector. A is a vector containing the values maybe 1, 2, 1. I think this is fine. Three-dimensional spaces there. B is also a vector containing values, let's say 2, 1, 1. So when I'm saying what is the value of norm of A or what is the value of norm of B, the simple meaning is, so I think everyone knows how can we evaluate a Euclidean distance. Euclidean distance, this is a way to evaluate the distance between any 2 points, right? Let me tell you those who are not aware, just in a brief context. If let's say you have point P1 available and having value x1 comma y1, and you will be having point P2 available having value x2 comma y2. So if I'll say that what is the distance between P1 and P2, that is where you will try to find the Euclidean distance, which is the square root of y2 minus y1 whole square plus x2 minus x1 whole square. Okay? That is the simple way to evaluate the distance between any 2 points. Always remember that. This is one of the, I would say, famous approach in almost all the data science domain to evaluate the distance between any 2 points. Even the word embedding algorithms in NLP, which is word to vec, I have talked about, they are also somehow internally using this kind of distance metrics. Now, when we are talking about this normalization or norm, we are trying to get a distance with respect to 0. That is why the formula gets changed to square root of 1 ka square plus 2 ka square plus 1 ka square. So it will be 2, 4, 5. I think square root of, no, 2, sorry, 1, 5 and 1. So 1, 4 and 1. So it will be 6. So square root of 6. So you can evaluate this. Similarly here also 2 square plus 1 square plus 1 square. It will be also equals to 4, 5, 6 square root of 6. So this is how basically we can evaluate the norm value. Is that fine for everyone? So basically, if I'll just change this x1, y1 point, if I'll change this x1, y1 point to origin, and I'll say that tell me, now if let's say I have the point which is x comma y, and this value is always 0 comma 0, which is the origin value. So now if I'll ask you what is the distance between this point P to the origin, what will be your answer? You will say that Priya, it will be x minus 0 square plus y minus 0 square. So internally, in other words, you are saying it will be x square plus y square. Same thing I have done to find out the norm of the values. I hope it is fine for everyone. Is it okay? Yup. Perfect. Now let's try to see with respect to data science where this specific knowledge is helpful, right? So if you will be able to observe that in maximum instances, if let's say you are dealing with any specific problem where you will be having let's say any numeric data, right, and you are doing a feature engineering task, and consider a scenario where there is a column name which is the units, number of units that they have sold is available to you. It can be 100, 200, 700, and unit price, like for individual unit what is the price it is given to you. um, Maybe let's say with respect to this product A, this is product B, this is product C. The unit price is maybe in this case it is 20, in this case it is 30, in this case it's let's say 10. Now these two columns are available, right? When you are doing an analysis, let's say you want to do an analysis in terms of total sales which they have done, and that column is not available to you. So when we are talking about feature engineering, you are dealing with the features to, you are trying to, you know uh, create some new features with respect to the given features if it is required to do your analysis done. So in this specific case, you will try to create maybe a new feature by the name of total sales. And what you will do inside that, you will try to do a multiplication of these two entities to get the final result, right? So this is what we also called as element wise multiplication, where you are taking the element step by step, 100, 20, you are doing a multiplication for the same, and you're getting the answer as 2000, then again 6000, then again 7000. So in this way you will be able to get the sales value. So all of these things, 100, 200, 700 is one vector, 20, 30, 10 is another vector. And what you are doing is you are trying to do a multiplication. I am again saying, let's assume that this is something which is not given to you, you are creating that. So how will you create that? That is where whatever knowledge we have gained till so far will be super helpful. So these kind of techniques uh, will be required in terms of doing the multiplication for the two units that we have. Apart from this, in terms of NLP domain, as I told you, when we are doing a evaluation of cosine similarity, cosine similarity, that is to check that how much two vectors are similar. That is where again this specific knowledge will come into picture. And if you have this idea, this core idea, you will be able to get the better understanding for the same. I think till so far everything is clear to everyone. Any doubts anywhere? After this, we have few matrix operations, like how can we do a addition of uh, two matrices? How can we do a addition for the same? How can we do a multiplication of any two matrices? Similarly, how can we do subtraction for the same? I'll not talk about these simpler operations. I really want you guys to, explore on your own. But let me talk about one of the most important function, which we usually use in this data science domain is multiplication. In almost CNN, all the algorithms, you will use this matrix multiplication operation. So let me take some time to explain you this aspect as well. There is one more operation which is very widely used as transpose, which I already have touched upon, that at any point of time, if you want to convert the rows into columns or columns into rows, that is where transpose operation comes into picture. So when we're talking about multiplication, let's say you are dealing with the image based data and you have the pixel values available. Now I'm just giving you one simple example, that let's assume that we have this matrix available having value 20, 30, 40, 45. I think I'm taking a very bigger value. So let me do one thing. For our easier calculation, let me take 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a matrix that we have, where if you will see by default, it will always start from 0. So this is the index number 0, 1, 2. This is also 0, 1, 2. This is what we called as columns. I hope everyone knows this stuff, right? This is what we called as columns. And this is what we called as rows in a given matrix. So if I'll ask you how many rows are there and how many columns are there, what will be your answer? How many rows are there and how many columns are there? It will be 3 cross 3. So it will be 3 number of rows and 3 number of columns will be there. Correct, everyone? Always remember, whenever we are doing matrix multiplication, there is a one simple rule. Whatever columns you will be having in the first matrix and whatever rows you will be having in the second matrix, it should be same. So it means that the number of columns are 3, so number of rows which you will picked up should be 3. Always remember. So let's say I'm saying I have the value 10, 20 and 30. So this is 3 cross 1. So what I'm saying is this value of matrix 1, number of columns, and this value matrix 2, this is M2, this is M1. M1 number of columns and M2 number of rows should be same. Then only the matrix multiplication will be possible. Always remember, that's a rule. So it will be in this case, we have 3 rows and single column. Now, if I'll ask you, how can I multiply M1 with M2? It's quite simple. So what we usually do, we take the element here row wise, here the column wise. So M1 into M2, which is the operation of matrix multiplication, how we do? We take 1 into 10 plus 2 into 20 plus 3 into 30. So I'm writing it over here. 1 into 10 plus 2 into 20 plus 3 into 30. Similarly, you can do the same thing for the below rows as well. 4 into 10 plus 5 into 20 plus 6 into 30. Similarly, 7 into 10 plus 8 into 20 plus 9 into 30. I think I am writing in a very bad manner now, but I hope it is clear. Due to lack of space, writing is not coming up clearly, but I hope it is fine, right? Now you can evaluate this term. So can anyone tell me what is the answers we are getting? So someone has told me it is 140260 and 500. I'm not sure it is correct or not. You can just verify. Everyone knows multiplication and addition. The main thing which I want to teach you here is that how basically these two matrices will be multiplied. So always take the rows and columns. That is how the numbers will be multiplied. One first condition I told you, that the number of, so it's let's say uh, m1 into n1. So it will be, let's say, m2 into n2, number of rows, number of columns, number of rows, number of columns. So always remember, n1 should be always equal to m2. ठीक है, first condition. Second thing, if I'll ask you what is the size of my final result, this is the final result, right? The final result size is, if you will be able to observe, it is nothing but 3 cross 1. So always remember, if let's say you have M1 matrix of size 3 cross 3 and M2 matrix of size 3 cross 1, so just remove these two common values, and whatever value you are left with is the final size. So even if you will not do any calculation and someone will ask you, what is the final size of a matrix after doing matrix multiplication operation? So if it is m cross n, and let's say it is n cross maybe o, so this n and n will be common. So always the size will be m cross o. I hope you're getting my point. So whatever be the common point you have, it's kind of, you can say, dissolve it out, and whatever be the value you are left with will be the final size of a matrix. I hope it is clear to everyone. Is that fine for everyone? So this is how basically the matrix multiplication will be done. It's super helpful in terms of a convolutional neural network. Maybe after today's session, you can go and check it out. Ki if let's say I will be having any image, on top of any image, we usually try to apply the filters. Maybe let's say whatever be the portion you want to detect in a given image, maybe the edges, maybe the area where the person is standing, whatever be the image portion you want to detect, as per that we have filters, and both of them are stored in the form of metrics. So maybe after today's session, even though you are not aware about deep learning stuff, it's okay. I think you will be just try to understand it, how this image and filter works together to get the final outcome, to get the final image, to get the final result of image recognition, to detect any object. Simple matrix multiplication is going on inside this specific part. So this is where the application of this specific topic comes into picture. Is that fine for everyone? I think this is something which I want to discuss in today's class. In the upcoming class, I'll touch upon the advanced topics of linear algebra, where we'll talk about eigenvalues and eigenvectors and all those stuffs. Today, I just want to give this much stuff. Try to consume it. Try to deep dive into the words or the things which you feel jargon for you. Just explore. That's it. I'm not saying that you should be aware about everything. You should not be. It's just that try start reading the articles, exploring the stuffs which are happening all around us. That is where you will start gaining the knowledge. Although you won't be able to get the 100% of it, but at least you'll get the awareness of the subject, and that is what I want from you. Okay. Perfect. Now you can ask me the doubts if you have. Otherwise, we can wrap up the class. Before wrapping up, just let me give you a brief recap of what we have covered up. We started our discussion with respect to the applications of linear algebra, where we have talked about data representation and manipulation. We have talked about model training. We have talked about dimensionality reduction. We have talked about CNN application. We have talked about in NLP how it is being used to give us the values as per the given context by doing a word embedding. Afterwards, we have talked a little bit about how this RAG and generative AI application is working nowadays. Afterwards, we jump towards the operations of vectors, where specifically we have talked about addition and dot product or multiplication. At the very end, I have touched upon the norm part. How can we evaluate a normalization of any vector A or B? And at the very end, I have just talked about the matrix operation, and inside that, multiplication for the same. Whatever operations apart from this which you feel I'm missing, I'm intentionally missing those things, because that is your task to just recap the things. If you will feel that there is some operation which I'm not able to understand how it is working, just you can let me know in the upcoming class. We'll start discussing with that stuff, and then we will move to the advanced portion. Is that fine for everyone?